Modern phones have a lot of interesting features. They're really quick. You can access the internet. You can play games. You can scroll Wikipedia, all kinds of other things. Right? You can even listen to music on Spotify. But then they lack one key feature. How do I plug this onto this phone? I look everywhere, and all I see is a USB-C port and a bunch of other holes, which are microphones, and then that's the camera. But that's it. So, how do I get around this problem? I thought let's build a USB-C to audio adapter. So, specifically a 3.5 millimeter headphone jack, so I can get around this problem. Sure, I could buy one. I mean, there's plenty of cheap adapters available on the market, but what's the fun in that? I'm an engineer. I'd like to solve problems, so let's get creative and start doing this ourselves.
Hello and welcome back to another episode of Electro Freak. Today we're going to tackle the problem of designing electronics. So, beginning of the video, I mentioned a problem that I'd like to solve, and now I'm going to introduce a workflow to try and approach and find a solution. Now, it might look electronics design might look like a maze without any lighting, but I can guide you through the process. There are a few steps to follow, and if you follow them, do your homework, you should be able to achieve your goals. So what I'm showing you right now is a basic workflow which you can use to design an electronic product. It might look kind of simple. In reality, these things are an iterative process. You'll have to go back and forth between steps. But right now, to begin with, we'll keep it quite simple. So the first thing you start with is defining requirements, because this is a very important part of the whole process. You want to define what you want your product to do. And it's important to have as much of it as possible done in the beginning, because skipping this and just going full on into designing something without any of these inputs can become very expensive later on. Fixing things in hardware after the fact is quite expensive. I can tell you that from experience. It's doable with small, simple products like what I'm trying to do here, which is an audio adapter, so USB-C to 3.5 millimeter jack audio adapter. And then, in small batches, you can correct mistakes later on and then redesign. But as you start scaling up in complexity and volume of production, it gets really sticky. So, very important step, define the requirements of your product. Specify what you want it to do. Once you're done with that, you can start researching components. This will happen on the electronic and mechanical level. You try to find parts online to satisfy these requirements. And mechanical design, which is also something you'll define your mechanical constraints in the requirement definition phase. So this can happen in parallel. If it's a one-man show, then you have to do everything yourself. But teams in the industry usually have, more than one person working on these things. But yeah, so that's research. Once you're done researching components, you put together a schematic. So this is where you put together your electrical design. You define the function of your circuit by connecting various parts together. So once you're done with that, you should do a review to see if your requirements are satisfied. I do plan on another video on schematic capture, so we'll go into more detail in that video. Next is PCB layout. So now you have your schematic. It's been approved. You're happy with it. Now you have the task of placing all these things on a PCB, and this is the physical part, right? So you have to place all these things on your circuit board and connect them. This is a mix of science and art. And what I can say for now is placement is really important. You look at where your connectors go, you place them first, and then you place all your other components to fit around these mechanical constraints, which I talked about earlier. And then you do a check in the end to see if you satisfy the basic requirements set forth by manufacturers. For our USB-C to a headphone jack adapter, I'm guessing a two-layer PCB would be sufficient. But yeah, we can go into more detail, and this is going to be part of another video. Then we have mechanical design, which usually is done in parallel to, you know, schematic and PCB layout. And this is basically defining what your packaging looks like and where the connector is going to be and all that. So this has to go hand in hand with the layout, right? Usually layout engineer and mechanical engineer work together, make sure everything is at the right place. And once you're done with all this, you order all your components. You order your PCBs, you order your electronic parts, and you can choose to either get them assembled or you can do that in-house. You could do the assembly in-house. I'm going to do external assembly for this project just to save time so we can focus on the design aspect, design and testing. So because hand assembly is quite time consuming, automated assembly is easier, which then brings us to testing. So this is where things get really exciting. So you connect your PCB, you power it up, and you use various tools like multimeters, oscilloscopes, what have you, logic analyzers, differential probes, optical fiber probes, all kinds of things to verify the function, depending on the complexity, of course, to verify the function. Some PCBs you might also have to program, if they have a microcontroller on it, you have to test if it's programmable and if you can update it and if the software works as intended. So this is an important, really, really important part and can be time consuming if you run into problems. But that's engineering. That's how it is, right? So it definitely helps to take your requirements and define a test plan for it. So you have your set of requirements which you define in the beginning, and you have your schematic and PCB, and then you have to test this. So you should define what and how you want to test things. So that definitely helps you structure the process. So once you're done with that, if you're happy with everything, you can go into final assembly, right? You can put all this stuff together, put it in the housing, and it's done, right? Ready to market. Usually, uh, there are a couple of loops. So you test stuff, you realize something doesn't work, you redesign it. So you'll have to change your schematic. It could be a simple change of a resistor value or capacitor value, same layout, just changing um, part values, or maybe a different op amp or a buffer with the same footprint, or it could be a whole new PCB. Depends on what happens, right? So this is an exciting phase of the project, and but also, of course, one of the most important parts. Um, and then you have final assembly, which is uh, if it's a simple product like this, it's one PCB that gets tested, and then you usually if these things are in series production, then you define automated testing strategy. So you don't, you can't test 100,000 PCBs by hand. That would take forever. you would define some test automation to do this for you. That's a separate topic, which we could touch upon in a future video. And so back just to you get back to the point here. So this would be a simple process. You have one PCB that you test, and if it's successful, you assemble it in your package, close the lid, sell it, right? What I didn't mention here was certification. So usually, if you want to market your products, you would have to certify it, especially things that operate with high voltages and also EMC, so which is electromagnetic compliance. You don't want this interfering with other products. You don't want this to be interfered with by other products, so that has to be done. That is something I'll introduce in a future video. We'll go into a bit more detailed workflow for all of these things. But now for our open source project, this is it, man. This is what we're going to do. We might have a couple of loops in between. Yeah, so that's it for now. And then I'll continue on to defining requirements. Okay, so now that we're done looking at this electronic design workflow, let's dive right into defining requirements. So like I mentioned in the beginning of the video, this is really important, and we want to lay down the foundations of our product. So we want to see, definitely want to define what the goal is. So the goal is obviously to build, in this case, a device that connects to the USB port of a phone and provides audio output through 3.5 millimeter headphone jack, right? The product should also let's frame it differently. So a 3.5 millimeter jack, and then enable charging of the phone, right? So that's what our goal is, and we need to break this down into requirements. So we have a section called must-haves. I'm going to write electrical. So you can see the format is pretty basic, but I'm not really focusing on the format right now. I just want to get the functionality, get the content in. Then we can always do any of these word styles to get a more beautiful format. Let's focus on the electrical and then also mechanical must-have requirements. Okay, so we'll start with electrical right now. So like I said, must connect to a phone using USB-C port. Must have a 3.5 millimeter jack for headphone audio, right? Because that's the main thing here. Must allow charging of connected phone via a USB-C cable, right? Okay, and we want to be able to also adjust the volume, right? So must be honestly, this is a kind of a refinement of this point here, but let's just put it as a separate requirement anyway, right? So must have adjustable audio volume. Okay. And since this is a product, this is a gadget or device that connects to a mobile phone, we need to take care that we don't reduce the battery life, don't consume too much power from the phone while idle, so let's put another requirement: must consume less than 100 milliwatts. idle, right? So these are the things I can think of right now on the electrical side. Honestly, I'd also like a switch. Must have a switch to enable, disable the device. Okay, so we'll put in a bit of a challenge, so then I'd like to have more control on this, right? So that's electrical must-haves that I can think of for now. These are going to guide my design process. I might find myself changing a few things. We can say that more or less these things are fixed. These are definitely going to have to be there, and then including this one as well, like less than 100 milliwatt. Although 100 milliwatt is what I have just uh, put in right now. This is a placeholder value. Honestly, probably we can change this to 50 milliwatt, right? So I'm just going to put a note here: research this in greater detail, right? So we'll just make this absolutely clear. 50 milliwatt is a placeholder value for now. Please research this. Greater detail and update if necessary. Okay, but the goal is clear. Like I said, I don't want to drain battery too much. And then I want a master switch to disable or enable the device. So those are the clear must-haves. Okay, now let's go to mechanical. So mechanical electrical requirements. Okay, mechanical requirements. So we are gonna have to put this into a casing, like a housing, ideally plastic, something that I could do 3D printing. This is going to be a small volume, so I don't want to set up injection molding and all that. So something that I can easily, yeah. So that's our very first requirement. So must be must be 3D printable, right? So okay. Now let's go into dimensions. I want to fit this into a case that isn't too big. You take a typical phone size. Let's just take my phone. My phone is about 6 centimeters wide. So 60 millimeters wide. So I would say, okay, 40 millimeter wide is what I would do, right? So it doesn't become too wide, doesn't exceed the width of the phone. So I want it to, fit in sleekly to to my phone. So let's see. So we'll write this like this: must not exceed width of phone, right? So now let's put some concrete numbers behind it. So must fit into casing, say casing, let's see. So you see that this is a somewhat iterative process. You see yourself or myself refining this as I go along. And this is something I might have to revisit some other time, but I'm trying to think out loud here to get as much as possible. So casing or housing, enclosure. Enclosure is actually the best word for this. Material must be 3D printable, must fit into enclosure. Whose dimensions are, so we said 40 millimeter wide. A maximum of divide times make this like only make about 30 millimeter long. No, probably we'll have to see. Probably I could get this even shorter. So times, let's say a maximum, right? Maximum 10 millimeter height. Right? So those are the requirements. Right? Next video we can put in a little bit more like a 3D model of this, just a dummy 3D model. We can play with some enclosure design in upcoming videos, and we can obviously just complete this document. I mean, complete it as in beautified a little bit, adding a few visuals, and we'll also go into block diagram. But I think this is good enough for now. Nice to have. Honestly, I really can't think of anything right now, except must connects to PC and provides audio outputs. Yeah. Okay, so let's wrap it up. Like I said, we've gone through the process of defining, the foundation or the requirements of what we want to do, and we've gone to electrical requirements, all the must-haves. What are mechanical requirements? Again, must-have mechanical requirements, and then one nice to have. So in the next video, I'm going to go into part research. I'm going to look for parts that satisfy these requirements. Now, it's up to me and up to you to choose the parts. Make it work. Right? This document does not say use part from this manufacturer or use part from that manufacturer. Right? I didn't put any such restrictions on this. There's honestly no need to do that on this kind of a product right now. So next video we'll go into part research. We're going to go and start looking at drawing a schematic, and we'll go. It's going to get more technical as we go along, right? So this was just to get you into it. I showed you the workflow. I showed you how to draft requirements, and I gave you the roadmap for upcoming videos. So hope you enjoyed this, and definitely subscribe, like, and stay tuned. See you next time.